Hello everyone, now we are going to solve aptitude questions of MPSC LDA which was held on September 13, 2025. So the first question we are going to look at is question number 127, and here it says look at the following series 2, 1, half and 1 by 4th, and what number should come next. So we have a series 2, 1, half and 1 by 4th. So if you look carefully in the series, each number is 1/2 of the previous number. That means if 2 is multiplied by half, we get the next number 1. Okay, and similarly, if 1 is multiplied by half, we will get the next number half. And similarly in this case. So to get the next number, we need to multiply 1 by 4th into half, and we will get the answer to be 1 by 8. Hence option B is the right answer. Okay, so the next question is question number 128, and here also is given a series 8, 22, 8, 28 and 8, and we need to find what is the next number. So in this series 8, 22, 8, 28 and 8, so here 8 is fixed, okay, and what is changing is 22 and 28. So the difference between this number is 6. Okay, so if we 22 if add with 6, we get the next number 28. So to get the next number, we need to add 28 plus 6, and the answer will be 434. Hence option D is the right answer. Okay, now we'll move on to question number 133. It says 3 prime numbers P, Q and R, each less than 20, are such that P minus Q is called Q minus R. So how many distinct possible values can we get for the sum P plus Q plus R? So we'll move on to the solution. From the question is given that P, Q and R are prime numbers less than 20. So let's list out the prime numbers that is less than 20, that is 2, 3, 5, 7, 11, 13, 17 and 19. So from the quotient, the first condition, it's given P minus Q is equal to Q minus R. So what is this condition is that this is in arithmetic progression, which means that it has a common difference. So if we take 3 values from the prime numbers that we have listed out, suppose 3, 5 and 7, and if we take the difference between 3 and 5 and 7, we will say have the same difference, that is 2. That means it has a common difference. Similarly, if we take a same prime number like 2 minus 2 and also 2 minus 2, this will be P and this is Q and this is Q and this is R, we will get the same difference, that is 0. Okay, so that is the first condition. So now the second condition is it says find the distinct values when we add P, Q and R. So here the distinct values means that the sum P, Q and R should have no similar values. It should only have one value for one number. Okay, so in the question now it did not mention that the prime numbers P, Q and R should be distinct. It mentioned that the sum P, Q and R should be distinct, but the number itself, the prime numbers P, Q and R, it did not mention that it be distinct. So we'll take the first case that P, Q and R are equal, and the possible triplets here. Okay, so this is, we have listed, this is P and this is Q, this is R. Now here if we take the common difference, of course you will get the answer to be 0, and the sum it is for 2 it is 6. Similar for 3, if you take the common difference, the sum will be 9, and solving like this till all the prime numbers is done till 19, we'll get all the possible values of p plus q plus r. Okay, so after solving this, we'll get a set of the possible triplets when p, q, and r are equal. Okay, so we have the set of 6, 9, 15, 21, 33, 39, 51, and 57. Okay, that is the case 1 we have done. We got the set for the case 1. Now for the case 2, when P, Q, and R are distinct, it means it has different values. Not like in case 1, we are subtracting or we are choosing P, Q, and R to be equal. Now we have to choose that the P, Q, and R should be different. So I am listing it again, the prime numbers here, so that you can solve for the distinct values. So if we start with 2, okay, if we start with 2, 2 is an even number, okay, and 3 is an odd number. And here also it's an odd number. So if we subtract between 2 minus 3, even and odd, it will never be equal. So we are cancelling out from 2 and we are starting from 3. 3 is an odd number and 5 is also an odd number. So if we start from 3, okay, we take the values 3, 5, and 7. Okay, if we take the difference between 3 and 5 and 7, we will get a common difference, that is 2. So the sum will be of P, Q, and R, that is 3, 5, and 7, will be 15. Now again, let's check again from 3. Do we get or not the more possible values? Okay, so if we choose the number 3 now with 7, the common difference here is 4. So if 7 is subtracted with 11 again, the difference is 4. Okay, so we can choose this also for the value of P, Q, and R, that is 3, 7, and 11. So the sum will be 21. Again, let's check if we have any other possible values. Okay, we have 3 and 11. Okay, what is the difference for this? It's 8. Okay, if we subtract 11 and 19, the difference also is 8. So we can also take that value 3, 11, and 19, and the sum here will be 33. Okay, so we are done with 3 since we have reached till 19, because the prime numbers it says will be less than 20. So now let's check for the value of 5. Okay, for 5 minus 7, the difference is 2. Okay, if we subtract again 7 with any another prime number, we cannot get the difference is 2. So we are not taking 5 and 7. We are jumping on from 5 to 11. The difference here will be 6. And we have to subtract 11 and 17. The difference also is 6. So we'll take the prime numbers 5, 11, and 17. Okay, and the sum here will be 33. Similarly, for number 7, check on again with like the same we did for the other numbers. So 7 minus 13 will be equal to 6, and 13 minus 19 will be also equal to 6. Okay, so you have ended up for 7 also till 19. So we cannot move on to the other values. So here we have 1, 15, 21, 33, 33, and 39. So these are the possible values of P plus Q plus R for when P, Q, and R are distinct. So here we listed out the set of this, okay, or this condition. We have 15, okay, we have 21, and since here the 33 it's appearing twice, okay, so we have mentioned it's distinct, so we will list it out only one. So 33 will be listed out only one times, 33 and 39. Okay, so here now for the distinct possible values when P, Q, and R are not equal, we will have a set of 4 numbers. Okay, so now to get the final answer, okay, to get the distinct possible values of P plus Q plus R, we will be doing the union of the when the P, Q, and R are constant and the P, Q, and R are distinct. Okay, distinct values of P, Q, and R. So I have listed out again the previous set. Okay, when the P, Q, and R are constant, So this is the set for PQ and R when are constant, and this is the set where PQ are distinct. So the union here will be 6, 9, okay, 15, it's appearing twice, so we're writing here only 115, and 21 also is appearing twice, you write only 121. 33 is appearing twice, so you write only 133, and 39 also is appearing twice, so you write only 139, and you have 51 and 57, 51, 57. So here we have a set of 8 distinct sums. Okay, so here in the option, it's option D will be the right answer, that is more than 6. Okay, now we'll be moving to question number 134. It says a train 120 meters long running at a speed of 72 km per hour. How long will it take to pass a man who is running at 18 km per hour in the same direction? Okay, what we need to find in this question is the time. Okay, so we'll note down what is given in the question. First, the train speed is 72. Okay, it is given in kilometer per hour, so we'll convert to meter per second. You multiply this by 5 by 18 and we get answer to be 20 meter per second. Similarly, the man speed, it is 18. We will multiply by 5 by 18. Okay, 18 and 18 will be cancelled and we get 5 meter per second. Now the relative speed between the train and the man is 20 minus 5, that is 15 meter per second. Now the time is the length of the train, that is 120, divided by the relative speed, that is 15. So 120 divided by 15. Okay, if you cut this with 5, this will be 3, and this will be 2 and 4. Okay, we'll cut again 3 with 24, this will be 8. So the answer is 8 seconds. Hence option D is the correct answer. Okay, now we'll be doing question number 135. It says, out of all the 2-digit integers between 1 and 100, a 2-digit number has to be selected at random. What is the probability that the selected number is not divisible by 7? Okay, so we'll check the solution, how to do. Okay, it is given number from 1 to 100. Okay, but it says only the 2-digit integers, so it'll be from 10 to 99. Okay, first you need to find how many numbers are there in between 10 to 99. So we'll subtract 99 minus 10 plus 1, that is 89, plus 1 is equal to 90. So 90 numbers are there between 10 to 99. Okay, next it says what is the probability that the selected number is not divisible by 2. So to know that the numbers are not divisible by 7, first we will see the multiples of 7, that means the number that are divisible by 7 between 10 to 99. So from 14 to 70, we all know the multiples from 14 to 70. So we have 9 multiples from here. Okay, 7 into 2 to 7 into 10. Okay, so we already have 9 multiples. And the next is 7 into 11 is 77. Okay, and 7 into 12 is 84, and then comes 91, and then comes 98. So how many multiples are there? 9, 10, 11, 12, 13. Okay, so we have 13 multiples of 7 between 10 to 99. So we'll subtract this with 90 minus 13, we have 77. Okay, so the probability here will be the favorable outcome, that is 77, divided by the total outcome, that is 90. Hence the probability is 77 by 90, which is option D is the correct answer. Okay, now we'll be doing question number 136. It says us to find the square of 1015 whole square. So what we'll do is we will solve this by a trick. Okay, for a 4-digit number, we can solve this by using this trick. So 15. Okay, we'll find first the square of just the 15 number. Okay, so 15 into 15. Okay, so 5, 5, 25, 5, 1, 5, 7, and 1, 5. Okay, so it's 5, it's 12, it's 2. Okay, so here it's 225. Now we will add 1015 plus 15. Okay, plus this 15 only. We will get here it's 0, it's 301. So the answer is 1030225. Hence option B is the correct answer. Okay, so next question number 137. It says the sum of the ages of 4 children born at the interval of 4 years is 36. What is the age of the youngest child? Okay, so we'll consider the age of the youngest child to be x. Okay, so the interval is 4 years among the 4 children. So the second child will be x plus 4. Okay, and the next child is x plus 8 because it is 4 years. Okay, 8 minus 4 is 4, and the next child is x plus 12. Okay, and the sum of the ages of the 4 children means x plus 4 plus x plus 8 plus x plus 12 is equal to 36. Okay, so here will be 4x plus 24 is equal to 36, and 4x is equal to 36 minus 24. That is, x will be equal to, this is 12 divided by 4, and the age of the youngest child here is 4. If you cut with 12, it is 3, so it is equal to 3 years. Hence option B is the right answer. Okay, so now we're doing question number 138. It says a 4-digit number n is such that when divided by 3, 5, 6, and 9, leave remainder 1, 3, 4, and 7. What is the smallest value of n? Okay, so in the question it says that if this 4-digit number n is divided by 3, leave remainder 1, and if divided by 5, leave remainder 3, and so on. If divided by 9, leave remainder 7. Okay, so this question is based on the concept of residue quotient. So what we'll first do is we will take the LCM of 3, 5, 6, and 9. Okay, so the LCM of 3, 5, 6, and 9, we'll start with 2. There will be 3, 5, 3, 9, and we'll start with 3. This will be 1, 5, 1, 3. Okay, we'll do with 3 again. Be 1, 5, 1, 1, and do it 5. It's 1, 1, 1, 1. So the LCM is equal to 2 into 3 into 3 into 5. So this will be equal to 90. Okay, and the question says that this number should be a 4-digit number n. Okay, here it is a 2-digit. We'll find the smallest 4-digit number, that is the multiple of 90. Okay, so we know that if 90 is multiplied by 10, it's equal to 900. Okay, this is still a 3-digit. Okay, we'll find 4-digit, the smallest 4-digit that is multiple of 90. Okay, if we multiply by 11, it is 990. If we multiply by 12, it is 1080. Okay, so we will take this as the smallest multiple of 90, that is a 4-digit. Okay, how we'll get the required number is the required number we will get by subtracting LCM minus residue. Okay, so where will we get this residue? The residue is got when we subtract this divisor. Okay, the divisor 3 minus the remainder 1, that is equal to 2. And similarly, if we divide or subtract all of this, 9 minus 7 is equal to 2. Okay, so the residue here, this is the residue. So the residue here, okay, it is 2. Okay, so the LCM here it is 1080. Okay, I'm taking this 4-digit one, not the 2-digit number. Okay? Subtracting with 2 will get 1078. Hence, option C is the right answer. Okay, now we move on to question number 139. Okay, what is the unit digit? What is the unit digit in the multiplication of 13579 till 999? Okay, so to find the unit digit here, we will look on the series. This is a series of odd number, and in this series includes the number 5. Okay, so in an odd series, when any odd number is multiplied by 5, the unit digit of the product is always 5. For example, if I take 1 into 5, it's equal to 5, and 3 into 5 is equal to 15, and 7 into 5 is equal to 35, and 9 into 5 is equal to 45. So you can see that the unit digit here is always 5. Okay, so on, if any product in this series of odd numbers is multiplied by 5, the unit digit will always be 5. Hence, option C is the right answer.